So far, our limit techniques have worked well for algebraic functions, like polynomials and rational functions. But sometimes, especially with trig functions, algebra isn't enough. That's where the squeeze theorem comes in. The idea is, if a function is trapped between two other functions, and those two outer functions both approach the same value as x equals a, then the function in the middle must also approach that same value. In simple terms, if a squeeze between two functions going to L, it must also go to L. Suppose we have three different functions, f of x, g of x, and h of x. If f of x is less than g of x, and they both less than h of x, and the limit of f of x as x approaches a equals L, and the limit of h of x as x approaches a also equals L, then the limit of g of x as x approaches a is L. That is the squeeze theorem. Trap the function, match the outer limits, the middle follows. Example 6. Evaluate limit as x approaches 0 of x squared times sine of 1 over x. First, notice something important. If we try direct substitution, the function is not defined at x equals 0 because 1 over x would be undefined. But that's not the main issue. The bigger issue is this. As x approaches 0, the expression 1 over x becomes very large, either positive or negative. And we know that the sine function keeps oscillating as its input grows. Since 1 over x growing without bound near 0, sine of 1 over x oscillating between -1 and 1. It never settles down to a single value. So direct substitution does not help us here. This is exactly when we need the squeeze theorem. Step 1. Use the basic fact about sine function. We know that for all real number, sine is always in between -1 and 1. Now, multiply every part of this inequality by x squared. Since x squared is always non-negative, so the inequality signs do not change. So we get negative x squared less than or equal to x squared times sine of 1 over x less than x squared. Negative x squared and x squared are my two outer functions. Next, I am going to take the limits of these two functions. Limit of negative x squared as x approaches 0 is 0. And limit of x squared as x approaches 0 is also 0. Step 3. Applying the squeeze theorem. Since the middle function x squared times sine of 1 over x is trapped between negative x squared and x squared, and both of x squared and negative x squared approach 0 as x approaches 0, then the middle function must also approach 0. So the limit of this function is 0. Now, let's look at the graph for a moment. The top curve is x squared. The bottom curve is negative x squared. And the middle curve is x squared times sine of 1 over x. Notice that the middle curve is always trapped between the top and the bottom. Even though it keeps oscillating, the oscillations get smaller and smaller as x gets closer to 0. And since the top and the bottom curves both approach 0, the middle curve is squeezed down to 0 as well. And that's exactly what the squeeze theorem tells us.